All right, we're going to tackle one of my favorite areas in the history of thought, the Enlightenment. And it's also a very complex era, and it'll take some time to unpack it. We're going to start by talking about the mechanical universe. We're going to demonstrate how this Renaissance value of humanism and the centrality of the human, man is the measure of all things, started to develop in the thought of the modern period. And in this section, I want the students to come away with three things. I want the student to examine the Enlightenment's relationship with Aristotle, Plato and Aristotle. I want the student to describe what we mean by the mechanical universe and how these principles led to that understanding. And finally, I want the student to evaluate how this mechanical universe, how the idea of a mechanical universe relates to the concept of God in a Christian framework. The medieval period was known for describing the world around it in more divine terms. It was the intervention of God into the natural world. Therefore, its practices, the church, its architecture, governmental structures, were based on the idea that God directs every little thing in the universe. But with the rise of humanism, with this rise of the idea of the human as an active agent in this world, we started to describe the world around us less in terms of direct intervention of God, and more in terms of an indirect intervention of God. It's not that God caused that thunderstorm to happen because he was displeased with something, but God created the hydrologic cycle. And in some lake or body of water in this place, the water evaporated and condensed and then fell. Notice how I phrase that. It was not necessarily explaining the universe without God, but it was a greater appreciation of how God worked in this world. Now, eventually, there was such a focus on discovering these different systems and principles and laws and such that God has established to what we call superintend the world, that some people were led to believe that they could explain the world without any relationship to God. But we'll get to those people later on. This is not how the Enlightenment started. It was not an anti-religious movement. It was the application of humanistic principles based on an Aristotelian lens for the world around us, through which we articulated our Christian life, through which we articulated a vision for how we relate to God. And the first figure in this is a guy named Copernicus. He was born in the late 15th century, died in the mid 16th century, 1543-ish, and he was a mathematician. He chose to apply his mathematics to the observation of how heavenly bodies moved. And he came up with a very revolutionary proposal to place the sun at the center of our solar system, the center of our known universe at that time. Now, this slightly modified the Aristotelian, also known as the Ptolemaic model that had Earth as the universe as its center. Now, I use the term revolutionary in quotes because the text that he wrote in order to declare this was De Revolutionibus Orbium Coelestium, the revolutions of heavenly bodies. This was a very clear departure from a geocentric universe. And this position was officially condemned by the Catholic Church. The Catholic Church did believe that the earth was the center of the universe. Why? Because the Bible says so, or at least in how they read it at that time. The Bible states that the sun rises and the sun sets. Well, if it's the sun that rises, and if it's the sun that sets, then it must be the sun in motion. A couple of things about that. We obviously would not agree with that interpretation of the Bible. We understand that God accommodates himself. God speaks in terms that you and I can understand. When the Bible says that his eyes are looking to and fro about the earth, does this mean God has eyes? No. When it talks about he's placing his feet on the ground, does God have feet? God describes himself as in the masculine. He describes himself as a father. And God has whatever reason he has for doing that. But does that mean that God has a male anatomy? No, but he describes himself in terms that we can understand. And that was not something that was widely understood, or at least not applied in this case. The church thought, since the Bible says the sun rises and the sun sets, then the Bible thinks that the earth is the center of the universe. It is a geocentric universe. Copernicus, in his observations, came up with a different conclusion, that the sun is the center of the universe, or a heliocentric universe. But at the same time, Copernicus did not understand everything that needed to be shifted from the old Aristotelian model. Aristotle believed that, in his theory of motion, that everything operates in perfect circles. So Copernicus assumed that the revolutions of the earth and the planets were in perfect circles around the sun. That obviously did not explain everything. Now let me just, as a little aside, let me tell you about the process of science. Science, to a certain extent, is very similar to history. Or at least the method of doing science is very similar to the method of doing history. And in some cases, it's similar to the method of writing fiction. Science is a narrative. It's a story. It is a story that explains all the data points that we have. Okay? So if our only data points are the sun rises and the sun sets, then the story that would make sense of that phenomena is that the sun goes around the earth. If we have more data points, we have to change our story. And we have to adjust our story to explain this new information. And with the advent of the new math that Copernicus brought with him, with the advent of new instruments, we started adding data points to this issue, and we had to come up with a new story to explain these new data points. Same thing with history. We'll have 3 or 4 documents on a particular time period, and we tell the story based on these data points that we have. And then eventually a scholar will find this other document about the same time period that doesn't quite fit the story that we originally mapped out. So then we have to change the story. We have to change the narrative. We'll get into this more in our discussion of progress, but it's important to understand how scientific change happens. Okay, and science is not necessarily brute fact. It's a human attempt to make sense of the brute facts that we collect. In some cases, this is similar to fiction. The only difference is we create the data points for fiction, and then we make a story out of it. The data points are not provided for us, but it's an analogous process. And for Copernicus, he looked at this new information, this new math, compared it, applied it to the motion of heavenly bodies that he saw, and had to write a new narrative, had to write a new story. This story was further changed by Galileo. Galileo was born slightly after Copernicus died and lived from the middle of the 16th to the middle of the 17th century. And Galileo gets a lot of the credit for these changes. He also took a lot of the heat for these changes from the Catholic Church because he was able to add new data points. And one of the reasons why why Galileo's work is so monumental is that the theory that Galileo was challenging was that of Aristotle. Aristotle had developed this theory of motion that we discussed earlier. This idea that like objects are drawn to one another, be it earth, air, fire, or water, that they are drawn to each other, and air and fire are drawn to air and fire, and that's why they go up, and earth and water are drawn to earth and water, and that's why they fall down. And the larger the object, the greater the attraction. So according to Aristotle, if you have a big ball and a small ball and drop them both from a 50-story building, the big ball will fall faster because it has a greater attraction than the small ball. Galileo challenged his theories of motion. Galileo claims that objects fall or move not because there's inherent attraction, because it is the nature of something in motion to keep moving, or it is the nature of something at rest to remain at rest. Now, this was not a full formulation of the theory of gravity or the theory of motion that Newton would offer us, and we'll get to him in a second. But it's a more accurately described how things move and how things fall. Galileo, let's take a cannonball through the air. According to Aristotle, that this cannonball is set in motion, and eventually the attraction downward would overcome the object, so it goes straight and then a rapid decline. According to Galileo, this trajectory would be a lot more gradual, and that's the trajectory we can observe today. Another example, if you have a sled on ice, and if you apply force to it and it moves, then you remove the force, that a sled will continue to move. It will slow because of friction, but it wants to keep moving. Is it being attracted by anything? Well, no. But things move because they want to stay moving. Things stay at rest because they want to stay at rest. This also led Galileo to challenge Aristotle in his theory of planetary motion. Aristotle explained the universe in terms of perfect circles. And this explains a lot of the phenomena we can see in the heavens, but it doesn't explain everything. For example, Venus. Venus is always in our view because of where it is in relation to us, but when you see Venus move, it moves forward and then it seems to move backward a little bit. And then it moves forward and then it moves backward a bit. Aristotle himself could not explain that. If things move in perfect circles, it should take a regular course. Some people try to use Aristotle to explain it, to say that Venus did not move in one perfect circle, but in a series of perfect circles. And that's why it looked to, kind of backtrack a little bit. Galileo had a much simpler explanation for that, and he developed the idea of the planets moving in elliptical motion, not perfect circles. Galileo was very innovative and took a lot of courage to challenge both Aristotle and the church. Remember, this time the church is a big fan of Aristotle. This is after Aquinas, this is after the Protestant Reformation, and the Roman Catholic Church explains its vision of the Christian life through an Aristotelian worldview. Galileo came and challenged that worldview. And if we want to see the most basic difference that Galileo had with Aristotle is in the idea of causation. When we talked about Aristotle, we talked about the four causes that cause anything in this world. And Aristotle believed that motion was a product of final causation. That something moved in order to achieve a particular final state. Earth and water were attracted down to the earth because its final state is supposed to be with earth and water. And fire and air would float up because the purpose of its final state is to be with other like things. And therefore he explained this attraction. Galileo did not explain the world in terms of final causation. Galileo explained the world in terms of efficient causation. Why does one object move this direction? It's not being attracted to something over there. It's because something banged into it from this side. That there is a cause and effect there. And this was a fundamental change in how we explained the world around us. How we explained the world around us. We had to change our narrative based on new information, and we realized that the old Aristotelian perspective on doing things was not as helpful as we wanted it to be. The third person we're going to talk about in this idea of a mechanical universe, a universe that operates on principles, is a big one, Isaac Newton. Isaac Newton was born in the middle of the 17th century and lived into the 18th century and wrote a series of books, all of which are important in their own right. The first of which we are going to discuss is his book called Optics. This book was not scientifically accurate, not by our standards. He tried to explain how vision worked and how sight worked, and we know more about the human body now. We know a little bit more about physics. So this work was not important because it was highly accurate. This book was important because it affirmed an Aristotelian worldview that we gained knowledge, we gained truth through observation, through sight. We gain truth by looking at the physical world around us. And that is our primary method of deriving knowledge. So Newton wrote his first book on optics because he wanted to establish the validity of observation. The validity of observation. This would make Aristotle and his empirical method, induction, etc., as reliable methods to approach the world around us. The more valuable contribution of Newton was his writings on mechanics. This idea that, that the world operates on laws or principles. A lot of these were not invented by Newton. A lot of these were ideas that were floating around in the scientific, philosophical community of the 17th century, and Newton pulled them all together and explained them in a systematic way. So we give credit to Newton for a lot of these ideas. But as we explained with Galileo, some of these ideas were already around there. And the three most important, most central ideas that we discuss when it comes to Newton is his three laws of motion. First, the law of inertia. An object at rest will remain at rest unless acted on by an outside or unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an outside or unbalanced force. In other words, objects move not because they are being pulled and attracted. They move because something acts on them. Not final causation, but official causation. And that object wants to continue to move unless acted upon by an outside force, be it friction, be it gravity, be it some other outside force, mechanical or human or otherwise. But it is in the nature of that object to want to continue to move or to want to stay at rest. Okay. Second law of motion, law of acceleration. Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. So things move in proportion to the force that acts on them. I was a baseball player at one point in my life, and this law is evident to every baseball player. I pitched. The more force I put in my arm, the faster that ball went. The more force the batter swung with, the further the ball traveled. Unfortunately, the batters I faced were much better at this principle than I was, and that is why I'm sitting here explaining philosophy. I still love baseball, but Newton didn't help me with that one. Newton did not help me with that one. The third law of motion that Newton promoted was the law of reaction. For every action, there's an equal and opposite reaction. If I were to hit that ball with 100 pounds of force, that ball is hitting back at me with 100 pounds of force. These laws, and I use the term law loosely, but it's appropriate in this situation, were revolutionary not because no one had ever observed this before. Obviously, these are principles that people had been observing for hundreds of years. What made this revolutionary is how he organized it and the implications of that. Instead of talking about a ball rolling, instead of talking in terms of, well, God must have wanted that ball to roll, God must have put that ball in motion, we have these principles and these laws that we use to explain it. Now, it's important to note that these were not laws, these were not principles that was in place of a God, at least for Newton, Galileo, Copernicus, and such. These were laws that God himself established as his method of governing the universe. So God did not necessarily have to directly cause every motion, but God established laws of motion that would govern things' movements. The theological term here is superintendence, that God superintends his creation, that God interacts with this world as a natural law giver. And if the world operates on mechanical principles, if the world operates in a manner that's predictable, that means that we can gain knowledge about the world and about God by observing this world. In the medieval view, where we did not have a well-developed sense of natural laws or superintendence, the world was not very predictable. And if the world is not predictable, then observing one phenomena is not going to help you when it comes to that phenomena happening again. We can't predict how that's going to happen. I guess one illustration of this, one classic illustration of this, is looking at the gods of ancient Mesopotamia versus the gods of ancient Egypt. When you look at the Nile River, the Nile would flood very regularly on a very set schedule, and the Egyptians were able to predict its flooding and were able to observe it, predict it, and then develop a agricultural plan that allowed them to harvest a lot of food, and that allowed them to flourish as a society. Also, when you look at Egyptian gods and goddesses, they tended to be a lot more kind and benevolent because the Egyptians held this worldview that the world is orderly and these gods aren't out to hurt them. If you look at the flood patterns of the rivers in Mesopotamia, they are not as regular, they are not as kind. So observing the flood one year is not going to help you develop an agricultural plan for the next year because it's not regular, it's not predictable. And when you look at the ancient Mesopotamian gods, they tend to be more mean and vengeful because it reflects the world that they see around them. As long as you have a predictable world that operates on laws, operates on principles, then your observation of it is valuable. Your observation of it can be predictable. And this idea of a mechanical universe based on an Aristotelian worldview was an enormous catalyst for scientific discovery, scientific pursuit. But I want it to be clear during this phase, this was not using science to explain the world around us in place of religion. That science was God's medium, God's avenue, God's method for governing his world. A couple other people that I want to discuss in this section are not scientists per se, but they are people that take this idea of a mechanical universe that can be predicted and applied it to theology, applied it to the Christian life. And one of these guys is a guy named William Paley, who was an English clergyman that lived in the late 18th century. And he articulated an argument for the existence of God that expounded on Aquinas' fifth way, an argument from design, what we call the Teleological Argument. And in Paley's essay, he tells a story. It's a very short and very effective story where him and a friend are walking through a field and he trips over a stone. And he asks his friend, "Why do you think this stone is here? Who put this stone here?" He said, "Well, God put this stone there. That stone has always been there. It must have been created by God in this field, and that's why you tripped over it." And he continues to walk, and he trips over a watch, a pocket watch. And quite facetiously, he asks the same question. "Who put this watch here? Why is this watch here?" Well, the conclusion is someone must have put it there. that since we see something that has a design, we must assume that there was a designer that placed that there. And this is a very simple but very effective argument. Anytime you see evidence of a design, that testifies to the necessity of a designer. If we don't want to use the term necessity, we can at least use the term reasonable. There's a reasonable expectation that someone designed it. And especially if you take Occam's razor, what is the more simple explanation for the existence of a pocket watch? That someone designed it and built it, or this thing just happened to appear randomly? I think the simpler explanation is a designer. So notice how this is an application of this idea of a mechanical universe to the argument for the existence of God. Since the world operates on mechanical principles and can be predicted, it gives evidence of design. And if the world operates on mechanical principles, then it is reasonable to assume that there was a designer of these principles. So Paley is incredibly illustrative for us at this point. The second theological figure we're going to talk about is a guy whose name at least is one of my favorite to talk about, Gottfried Von Leibnitz. He lived in the latter half of the 17th century, early 18th century, and evidences new approaches to historic questions of the Christian faith. He was a mathematician. He developed calculus independently of Newton. While Newton was working in England, Leibniz was working on the continent, and they both independently developed principles for calculus. So it's very interesting that we have these mathematicians, we have these scientists, although scientists may not be an appropriate term for who these people were in this time period. They were philosophers. They were philosophers that applied their craft to observing the world around us, and that's why we call them scientists. They would call themselves philosophers. Leibniz applied his idea of a mechanical universe to the existence of evil. And it is, if not persuasive, at least highly interesting way of looking at this. Now, let's review a little bit some of the answers that we have run into in the past, namely Augustine. Augustine put forward one of the most powerful arguments for how there can be a God who is all good and a God who is all powerful, but yet evil is still in existence in this world. I think it's interesting when I ask students this question, the very first answer they offer is free will, free will, free will. It's interesting that Christians prior to the 18th century did not default to free will in this question, and I think they had it right. I don't think free will explains the existence of evil sufficiently. If for no other reason, evil was introduced into this world not by man but by Lucifer before, it seems to suggest before man was even on earth, before man had an opportunity to exercise any will, evil still existed in the universe. Now we might be able to use free will as an explanation for how that was applied to humanity on this planet, but it's not really an explanation for why it exists in the first place. Augustine's explanation is what we refer to as privation or perversion. In other words, God created everything good. Therefore, evil, it cannot be a thing. Evil is no thing. Evil is nothing. So evil is the absence of good. This is highly attractive because it allows us to maintain some core biblical convictions. First one is that evil is real. Evil is around us. It's not just lack of education. It's not just lack of resources. It is a reality. Secondly, that God is not the author of it. We cannot blame God for the existence of evil, yet thirdly, God is all-powerful. He created everything good, and He Himself is all good. We have to maintain those three in whatever explanation we give from a Christian perspective. It's interesting from an Islamic perspective, they have no problem saying that God is the author of evil. because God can do whatever he wants. God is absolute freedom. That's their central organizing principle. Our central organizing principle, or principles, are derived from the Old and New Testaments that says that God is love and God is good and God is just. And when the Bible says God is not the author of evil, we have to take that seriously. Leibniz has a very interesting approach to this. Leibniz says that God created the world. Nothing revolutionary there. God created the world. And creation necessarily has to be separate from God. In other words, creation is not simply an extension of who God is. Otherwise, that would be a pantheistic worldview. This idea that everything is God, trees are God, grass is God, all this is an extension of God, or at least panentheism, that God is in all things. As Christians, we cannot go down that road of pantheism or panentheism. Instead, we think that God created the world, and the world is by definition separate from God. Creation and creator are necessarily two distinct things. Okay, if we believe that one of the essential qualities of God is his perfection, and if we believe that creation is not God, then by definition, anything God creates that is not God cannot be perfect. Cannot be perfect. And this is where we get the idea that the phrase here that God created the best of all possible worlds. That creating a perfect world was not an option. Because if the world is perfect and the essential characteristic of God is perfection, then we have two options. Either the world is God, the world is an extension of God, and that would be pantheism, and we don't like that. Or creation by definition cannot be perfect. So the way God created this universe, by definition, has to be imperfect, has to be not God. I find this very interesting. I don't know if I find it persuasive or convincing, because then it raises questions on, okay, what can God not do? And I think we've already mentioned this offhandedly, that there are some things God can't do. God can't lie. God can't change. In our Christian perception of who God is limited, but he's unique in that he's limited by his own character. That's the only thing that limits God. So to be consistent with that, I think Leibniz's solution is possible. And I think it's an interesting thing to think about. I don't know how much comfort that would give us pastorally, but philosophically it's very interesting. The other thing I find interesting about it is to give you a little balance here. Is this a method, is this answer to the existence of evil that Leibniz proposed? Was this developed by looking at the world around us? Do you have to observe the physical material universe in order to come up with this formulation? I'd say no. This is more rationalistic than empirical. This is based on definitions of who God is. You can be blind and deaf and still develop or follow this argument. So Leibniz stands as an illustration that even though Christianity had by and large articulated itself according to Aristotelian principles, it's not like the Platonic vision for the Christian life was obliterated or completely abandoned. We do have these philosophers that are using these two different methods side by side. When we talk about this era more Aristotelian, we're talking about in emphasis. We're not talking about it is absolutely the only thing that occurred. So it's not historically accurate or helpful to talk about Aristotelianism and completely ignore the Platonic method. So I think Leibniz is a great illustration of the influence of the Platonic method even during the Enlightenment. This was a lot of information, and it was a very quick tour from Copernicus to Galileo to Newton, And then Paley and Leibniz is this parallel but somehow different track. But I want you to understand how this idea of the mechanical universe arose from humanistic principles and how it did not necessarily shove God out of the mix, but it was a new way to articulate our Christian life. There's a lot more here than we have time for, but I'm sure you're glad that this lecture is over for now. Thank you.